Ask almost any school child how the first people arrived in the Americas, and the answer comes easily, repeated so often it feels unquestionable. Brave hunters wrapped in animal furs crossing a vast land bridge that once connected Siberia to Alaska. A frozen plain exposed by falling sea levels at the height of the last ice age. That lost world had a name, Beringia. From there, the story continues, they marched south through a narrow passage between towering walls of ice, entering a pristine continent filled with woolly mammoths, giant bison, and endless horizons. For decades, science embraced this narrative. It was elegant, logical, orderly, and it seemed to match the evidence, especially a distinctive set of stone spear points found scattered across North America. Known as Clovis points, these finely crafted tools dated to around 13,000 years ago and were long considered the unmistakable signature of the first Americans. According to the Clovis-first model, a single technologically advanced culture crossed Beringia, passed through an ice-free corridor in Canada, and rapidly spread across the continent. The idea became scientific dogma. But science rarely remains neat for long. In recent years, a growing body of evidence has begun to fracture this once solid story. At Paisley Caves in Oregon, fossilized human DNA was dated to more than 14,000 years ago, older than Clovis. Then came an even more astonishing discovery. At White Sands, New Mexico, ancient human footprints pressed into an Ice Age lake bed were dated to nearly 23,000 years ago. People were in North America far earlier than the Clovis timeline allowed, and they were already thousands of miles south of the continental ice sheets. This created an unavoidable contradiction. If humans were living deep within the Americas more than 20,000 years ago, how did they get there?
At the time, the northern half of the continent was sealed behind an almost impenetrable barrier of ice. The answer, or the failure of one, lies in a narrow strip of land in present-day Canada, the ice-free corridor. For years, archaeologists assumed that once this corridor physically opened, humans simply walked through it. But a new groundbreaking study asked a deeper question. Not when the ice melted, but when life returned. North America 20,000 years ago was an alien world. Two colossal ice sheets dominated the landscape. The Laurentiide ice sheet stretched across eastern Canada, while the Cordilleran ice sheet smothered the western mountain ranges. Together, they merged into a single frozen wall, miles thick, blocking all passage from Alaska into the interior of the continent. As the Ice Age began to wane around 15,000 years ago, the glaciers slowly began to retreat. From north to south, a narrow gap opened, roughly 1,500 kilometers long, and in places only a few dozen kilometers wide. This was the ice-free corridor. For decades, it was assumed that humans used it the moment it opened. But a path can be physically open and still be utterly deadly. A barren landscape of mud, meltwater, exposed rock, and freezing winds is not a corridor. It is a death trap. To cross 1,500 kilometers, ancient travelers would have needed fresh water, firewood, edible plants, and large animals to hunt. You cannot carry months of food on your back through a frozen wasteland. You need a living ecosystem. So researchers went looking for one. To determine when the corridor became biologically viable, scientists traveled to its narrowest bottleneck, the last region to emerge from beneath the ice. This area, spanning parts of modern-day British Columbia and Alberta, was once submerged beneath a massive glacial body known as Glacial Lake Peace. Drilling deep into the sediments of two modern lakes, the final remnants of that ancient water body, the team extracted sediment cores that functioned as precise time capsules. Each layer preserved traces of the world above: pollen,
microscopic fossils, chemical signatures. But this time, researchers searched for something even more revealing: environmental DNA. Known as eDNA, it is the genetic residue left behind by life itself, shed from plants, animals, bacteria, waste, and decaying tissue. Because DNA binds to fine sediments, it can remain preserved for tens of thousands of years. This technique allows scientists to reconstruct entire ecosystems, even when no bones or fossils remain. And what the DNA revealed changed everything. Although the ice began retreating around 15,000 years ago, the corridor remained biologically dead for millennia. As late as 13,000 years ago, the exact moment Clovis people were thought to be using this route, the region was still a sterile landscape, flooded by icy meltwater, choked with sediment, devoid of soil, plants, or animals. There was nothing to eat, nothing to hunt, nothing to burn. The corridor was impassable. Then, around 12,600 years ago, something remarkable happened. The DNA record shows the sudden arrival of the first pioneer plants, hardy steppe vegetation like sagebrush, tough species capable of surviving brutal cold and dry winds. Once plants took hold, animals followed. The genetic signatures of bison, woolly mammoths, and jackrabbits appeared in the sediments, drawn northward by new growth. By 11,600 years ago, the region transformed into dense boreal forest dominated by spruce and pine. Only then did the corridor become a true ecological highway. And that leads to a stark conclusion. If the ice-free corridor lacked the resources needed to support human life until 12,600 years ago, then no one could have crossed it before that time.
Yet humans were already living in the Americas thousands of years earlier. The corridor was not the gateway, it was a dead end. For the first Americans, it was a closed door, which means they did not go through the continent, they went around it. This has forced science to look west, toward the sea. The coastal migration theory, once dismissed as speculative, is now the leading explanation. It suggests that early humans traveled along the Pacific coast, moving south from Beringia by boat, navigating a chain of islands and ice-free shorelines. They followed a kelp highway, a rich marine ecosystem teeming with fish, shellfish, seals, seabirds, and seaweed. While the interior of North America was locked beneath ice, the coast offered a continuous, abundant food source. It was not an empty wilderness, it was a corridor of life. This does not mean the ice-free corridor was never used. Once it became fertile, it likely served as a major route for later migrations, but it was not the path of the first pioneers. Those earliest people did not wait for the ice to retreat. They adapted, they sailed, they found another way. Thanks for watching. If you found this video insightful, consider liking, subscribing, and sharing your thoughts in the comments below. We look forward to hearing your perspective. Farewell.